Computación inspirada en el cerebro, un cambio radical para la eficiencia energética de la IA.
Artificial intelligence systems are consuming rapidly increasing amounts of electricity, raising concerns about sustainability, cost, and the environmental impact of large-scale computing. Recent research reported by several technology and science outlets suggests that new brain-inspired computing methods may offer a practical path to easing this growing energy burden. According to reports published in mid-December, researchers have proposed alternative approaches to how AI systems are trained and run. These methods take inspiration from the human brain, which remains one of the most energy-efficient information processing systems known. The studies focus on reducing the energy required for tasks such as training large AI models, a process that currently demands significant computing power. The coverage highlights that the energy demands of AI are no longer a theoretical issue. As AI systems expand in size and complexity, their electricity consumption increasingly rivals that of entire cities or even small countries. This has intensified interest in computing models that prioritize efficiency alongside performance. The newly reported research positions brain-inspired computing as a potential solution to this challenge, offering a way to maintain AI progress while reducing its environmental footprint. The human brain performs complex cognitive tasks while consuming only a fraction of the energy required by modern computers. Researchers featured in recent reports are seeking to replicate some of these principles in artificial systems. One approach involves analog computing, which processes information in a continuous way rather than relying solely on digital signals. An article from Tech Explorer describes a new analog computing method designed to significantly cut the energy used during AI training. By carrying out calculations directly where data is stored, the method reduces the need to move information back and forth between memory and processors. This data movement is widely recognized as a major source of energy consumption in conventional AI systems. Related coverage from Frontiers focuses on what is known as the memory wall, a long-standing limitation in computing where energy and time are lost moving data between separate memory and processing units. Brain-inspired algorithms aim to address this by bringing computation closer to memory, in a way that more closely resembles how neurons and synapses work together in the brain. Other reports point to neuromorphic computing, which uses specialized chips designed to mimic neural structures. According to Inside Telecom and Space Daily, these chips process information in a more brain-like manner, potentially enabling AI systems to perform tasks using far less power than traditional hardware. Early results reported in these studies point to substantial energy savings. A report from WebPro News highlights research suggesting that brain-inspired AI systems could reduce energy consumption by as much as 99% in certain applications. Such figures, if confirmed at scale, would represent a major shift in how AI systems are designed and deployed. However, the coverage also reflects a cautious tone among researchers and industry observers. While laboratory results are promising, translating these methods into commercial systems presents challenges. Reports note that new hardware designs, such as analog processors and neuromorphic chips, would require changes across the AI software stack. Frontiers emphasizes that overcoming the memory wall is not solely a hardware problem. Algorithms must also be adapted to take full advantage of brain-inspired architectures. Inside Telecom adds that the success of neuromorphic systems will depend on whether they can be produced reliably and integrated into existing technology ecosystems. Taken together, the expert perspectives presented in these articles suggest that while the potential energy savings are significant, widespread adoption will require coordinated advances in hardware, software, and manufacturing processes. The potential impact of brain-inspired computing extends beyond technical performance. If these approaches can be deployed at scale, they could significantly reduce the energy costs associated with AI, making advanced systems more accessible and sustainable. WebPro News and Space Daily note that lower power requirements could ease pressure on data centers, which are facing growing scrutiny over electricity use and carbon emissions. More efficient AI systems could also enable deployment in settings where power is limited, such as edge devices or remote locations. Inside Telecom highlights that neuromorphic and brain-inspired designs may influence the next generation of computing hardware. Rather than focusing solely on faster processing speeds, future systems could prioritize efficiency and adaptability, reflecting lessons learned from biological intelligence. While these developments remain at an early stage, the recent reports suggest a clear direction of travel. Brain-inspired computing is emerging as a serious contender in efforts to make artificial intelligence more sustainable, potentially reshaping both the economics and environmental impact of AI in the years ahead.
Este sitio puede ayudarte a mejorar tu comprensión de lectura y escucha en inglés. Use inteligencia artificial para dividir las oraciones en partes fáciles de entender. Con el reproductor puedes ajustar la velocidad, pausar o retroceder para entender cada frase. Ofrece traducción a 20 idiomas, lo que facilita mucho el aprendizaje. Solo escribe inglés.com en tu navegador y pruébalo ya.